Cue it up. All right, everybody. Welcome to another OpenShift Commons Ask Me Anything AMA session on a Monday. And this time we have with us some of the folks who've been working with Telepresence, and they're going to explain what that is, and they're going to talk about Telepresence with Istio. So we have Aslak and Bartosz both here today, and so I'm going to let them introduce themselves. They're going to talk about what these projects are, how they're all interrelated, do a bit of a demo. We'll have live Q&A in the chat, and at the end we'll have some live Q&A with the maintainers and the project leads here as well. So without any further ado, Aslak and Bartosz, please introduce yourselves and take all the time you need.
Okay, Aslak, you want to go first with the introduction? Because your name is
sure. I can start. My name is Aslak Knutsen, and I'm from Norway, and currently working on a project called the Istio workspaces, which we're going to be showing. Bartosz?
Right. So I'm Bartosz, originally from Poland, now living in Switzerland. We both work on the same project. We are both engineers. Okay, so I will just jump into the slides. So the topic of our presentation and then the demo is showing you how Telepresence can work with Istio and how it leads us to safe development on production. And when we say we should develop on production, people very often react like we are actually crazy. So during this presentation, we would like to show you those tools which we believe make this vision a reality, and actually let you do that without fear. So if we think about development, we can actually think about loops or cycles. And the first one where we all work in is a so-called inner loop. So this is everything what happens prior to commit and push. So essentially we translate our great ideas into code. We run them, we validate them. If we see some problems, we probably debug them, and the cycle goes on. And in the world of monoliths, that was fairly straightforward task. It was quite easy to reason about the code base. It was easy to debug, and it was most importantly very easy to spin up the whole app locally. And as we move to the distributed systems, we kind of assume that this will work the same way. And obviously, if we start small and we just have a bunch of containers and tools like code-ready containers or Minikube, it's actually fairly simple to spin up the whole cluster and just work with the app. But we all know that reality is a little bit more complicated. We don't have 4 services. We could obviously start with 4 services and so 4 containers. But as we grow, we're gonna end up with dozens, if not hundreds of services. And the desire to run this whole stack locally is close to impossible, to realize that it's actually close to impossible. Because even if we think about the services based on Go or GraalVM, so Quarkus Java framework, even if it's, let's say, 30 megabytes of RAM, if we multiply it by 100, and then we run cluster on the same machine, and then we add Istio and all the other goodies we use in the cloud environment, it can very quickly turn to be something like this. And I mean, if I try to run things on my machine, I very frequently reach more than 90 degrees Celsius. Might mean that I need to change my thermal paste, but it's also consuming tons of RAM. So there are several tools in the ecosystem which actually let you ease the pain and not forcing you to run, in quotes, the whole cloud on your laptop. And one of them, which is part of the CNCF sandbox, and one which we are quite impressed by, is Telepresence. Telepresence is a tool which, in a first simplification, acts as a bidirectional proxy, and it lets you run your service locally like if it would be a part of your cluster. So essentially what happens is that Telepresence will swap your deployment in the cluster and install a proxy in there and reroute the whole traffic back to your local machine so that you can use all the tools you like to develop, debug, and work with the code, but only which are necessary on your local machine. And then you communicate with all the other services directly in the cluster. So that's where Telepresence brings you a very fast local development without making your machine sweat or set on fire. But then, when we are done with our local changes, we most likely would like to validate them against the bigger picture. And here's where the so-called outer loop kicks in. So this is what happens after the push, so that we build our new code on the CI server, we run some integration tests, we deploy, and eventually we accept it manually or automatically, and we ship it. But then there is this uncertainty. Then we are uncertain. Will this stuff actually work on prod? And we most of the times are not that confident. So to mitigate this challenge and to reduce the risk, we frequently choose to have some other environment to verify those things before they hit the actual user. So with the staging environment, there are certain challenges we have to keep in mind. First of all, it's quite hard to keep it in sync with prod, and mainly about having the similar data sets and the volume of this data and the traffic. Then there are obvious extra costs. Let it be, we have to have people who maintain it, and we actually have to have infrastructure to run this whole stuff. And at the end of the day, we are not really sure if when we promote the changes to production, this will still work. Because it can be different down to the infrastructure level, so that we can hit some unforeseen issues. But on top of that, it's actually a very slow process. The feedback loop takes a long time. So if we would be able to do it faster, then we would be really productive. So what if I tell you that there's actually a combination of tools which will give you the experience of local development and confidence of shipping your changes to production without having a lot of risk. And that's how the Ike tool was born. So we came both from a project which was a software as a service, and we learned all the pains of working with the cloud environment and with all these challenging bits which I just have mentioned. So we thought we need to find some way to make this easy and to make developers productive again. So we started with 3 simple goals. The first one was easy way of validating your changes, but without messing around with other services and users. But we wanted to actually use the services in the cluster. We didn't want to run everything on our local machines. And obviously, as we all have our favorite tools of choice when it comes to writing software, we wanted to use them. We didn't want to have something enforced or some other thing which we will have to use. So Ike is 2 things in one. It's a Kubernetes operator which will coordinate the cluster setup and all the changes which are needed in order to make this magic works. But it's also a CLI tool for local development. This works on vanilla Kubernetes, but we also make sure that it works on OpenShift. And we use Telepresence as one of the strategies. Telepresence, we also contribute to Telepresence, as I said, because we want to make sure that it works on OpenShift. So we submitted a bunch of patches to make it happen. But in order to fulfill the goal of not messing up with the others, Telepresence on its own, it's not enough. Because it targets the given deployment, but it's all or nothing. So it will replace the deployment and then the whole traffic will go through it, which means not only us will be able to see it, but everyone else who is using this cluster will also be using these new changes. So we need something more in order to bring the safety. So we looked at Istio. Because there is one very important feature which let us make this dream come true. And this is the splitting of the traffic. So we have a very easy way by using Istio to say, based on certain conditions, let this request go to this new service, which we just developed. And all the other, so let's say the regular traffic, will still go through the known path. So before we dive into the demo and show you everything in action, let's just have a quick 30,000 feet overview of what kind of app we are dealing with here. So it's a fairly sophisticated micro app, which consists of 3 services. And what you are about to see is following. We're gonna work in 2 areas. We will have a local development on the recommendation service by using Telepresence, and we will be introducing our changes locally. But we will also show you a way of validating your changes which are coming in the pull request. So we will change 2 services as a pull request and also have a very similar way of validating it only for those who can, not for everyone. And as we are talking about pull requests, we obviously need some machinery to make it happen. So we're gonna use Tekton as a part of our demo. So I guess from my side, for now, that's all I have when it comes to nice pictures, and I will hand over to Aslak to show you Istio workspaces in action.
All right. So, oops. I'll share my screen and start the demo process. So yeah, as Bartosz was showing, this is the demo app running. It's a customer service calling a preference service, which is calling the recommendation service. Doesn't really do much, but it still it gives you the general flow of things. So as a developer now, I want to make a change to the preference service, and we're assuming that this environment is now our production environment. So I just want to go down to my laptop and start up a local instance of the preference service. And it's then going to be running within the cluster. So we're actually calling a command called develop, and we're saying that we're going to use the deployment preference version 1 that is in the workspace demo namespace, and it's a Quarkus-based app. So we're going to run the Quarkus command. So as you can see on the slide there, a new service has been deployed, and it's about to start locally. We have a little watch script that we have here. So the first section is the production route. The second one is one of the routes, and the next one, And the third one is the pull request route that I'm going to show later. It's what it does. It's just doing a curl on the specific domain names. So it's the Ike demo IO, which is the production one, and then it's the feature Y Ike demo IO and the feature X Ike demo. Currently, only the feature Y and the production route exists. That looks like it. So as far as you can see on the watch, there's no difference between the two routes at the moment. And the reason for that is that we're running the same version of the preference service in production as we're doing locally. If we go into the preference service source code and make a change, Arcus will pick up a change in dev mode, and we can now see that the local route changed as well. So this is the production version of, or the production instance of the customer service calling a local instance of the preference service, which is calling back out to the production instance of the recommendation service. So how does that actually work? So all of these services have Istio virtual services. So we're changing the preference service. So our operator on the cluster side is actually listening to a bucket, which the command line is creating. That consists of essentially saying that we want to target the preference service version 1. We want to use the telepresence strategy, and we want to route it on some specific headers. Beyond that, it's just kind of printing out what it changed. So we can see that it has created a new deployment. It has modified a destination rule. It's modified a gateway, and it's modified two different virtual services. So if we look at the virtual services, what has actually happened is that originally it only had a route to the preference service version 1, but our operator then went in and added a specific match so that if a certain header is present, that traffic will be rerouted to the version 1 feature Y deployment, which is the proxy of the locally running service. And same with the destination rules as well. It's been added a new subset. So let's assume that now we're gonna make this called PR, and we're happy with that change. We want to shut down the local version. Want to create a branch for feature X. We push that to GitHub. And we can open up a pull request for it. Okay, here we go. Our GitHub repo is then set up to kick off the Tecton pipeline. Up here, it's a bit of a strange pipeline at the moment, but it's a monorepo setup. So it's doing a clone, and then it's figuring out whether it's going to be building the recommendation service, the preference service, or the customer service. And then it will build it, create an image, and then trigger another ike command, which is essentially ike create. Will take a few seconds at least, so we could look at some of the tasks there. So there's an ike create tecton task that's similar to the ike develop command, but it will take an image instead of a local process. So a pre-built image can be deployed in the same way. Yeah, I'm not sure if there's much point of watching the actual pipeline YAML file. It's a bit of a mess. What we're waiting for to happen now, right? We're going to see in the watch script that there's going to come up a hit on the pull request route as soon as it here. So this kind of functions as a pull request preview option, so that you've made a change and now you have the option to kind of share that change with multiple people. So it's running in the production environment, but still within a hidden route. And here now the pull request is up and running. So that's the image that is running. If we look at the session this time, instead of the strategy of telepresence, it will now have a strategy of prepared image and a reference to the image. And also, just for the fun of it, it's added a comment saying that, hey, you can see the changes in this URL. And now imagine that either some test cases or something failed on this pull request when you were interacting with this second service, and you want to debug essentially what is going on in the recommendation service when this specific change of the preference service happened. So as the Istio workspaces has a feature where you can essentially join in on the same route. You can start up a local version of the recommendation service. It's still using ike develop, but specifically it's saying that we want to join the feature X session. So it's reusing the same outing information. And we can now see that there's something happening. At least in a few seconds, we should have the local recommendation service up and running and receiving requests. 1 request, 2 requests. So that's the production instance of the customer service calling the preference service instance that was built by the pull request, and then calling into the local version of the recommendation service. At this point, you could connect the debugger to it and do whatever you want. And then also imagine that there's another developer who want to do something, some other change to some other service. In this case, the preference service. So that person could start it up as well, locally on his machine. And here,
Aslak, you might want to show Kali, I guess, just to get some visual aspect of the whole service graph.
it's coming. It's coming. So at this point, we'll still seeing that this is the pull request version, but let's just pop that back to see the difference. There we go. So now this route is the production version of customer calling the local version of preference, calling production version of recommendation. And this route is the production version of customer calling the pull request version of the preference service, calling a local version. And looking in Kali, it looks a little bit like this. New version of Kali orders those a bit strangely, but anyway, we have the customer service on the left hand, the preference service in the middle, and the recommendation service on the right. And we can see there's three versions of the preference service. It's the production version, the pull request version, and a local version. And for the recommendation service, it's the production version and the local version, which is part of the pull request version. And similarly, of course, we can shut everything down again, and the world should return to normal. Request. Local route disappeared because there's nothing running. As soon as cleanup is done. But maybe the most interesting part about this demo is that at no point did this change. The production route always stayed the same, which makes it a safe route, essentially. And that's it for the demo, unless you have something to add, Bartosz.
I think we pretty much are done with the demo.
Yeah.
Jump to Q&A right away.
Yeah, so I have I mean, this is awesome stuff, all right, and I really love it, but I think I'm having a little mental breakdown around some confusion around different projects, because, and if you want to jump over and share your screen, Bartosz, with the getting started docs, maybe, to
sure.
Just so that we can use that as a jumping off place for folks to have conversation and questions. But so as you know, anyone who ever looks at the CNCF landscape document gets confused like right off the bat. There are so many projects out there. So and when you go to GitHub, this is in Maestra.
Right, that's correct.
So maybe explaining what Maestra's relationship to Istio is to OpenShift might be a good start here, and not that you're responsible for that relationship, but just to cue that, and then maybe talk a little bit about, start there. How's that?
Okay, so Maestra is our downstream name or code name for all the projects Istio we are doing. So we do have the OpenShift service mesh, and that's the Red Hat version of Istio. And this, as far as the code sits, is in the Maestra org. Right, so we do contribute patches upstream. Obviously, we work with the community, but we also do have our own things which need some space to exist, and this is the Maestra org, essentially.
Yeah, Okay.
Our project is called Istio Workspace. It's not part of Istio. It's a standalone component. It leverages Istio and it leverages Telepresence. So this is where those two meet, as we were demonstrating in the live demo. So we use the Telepresence to give you local development experience, and we leverage Istio to have a safe way of doing so in the cluster. So this is our repository, and we do have a bit of a README here and a link to the demo, which is fairly similar to what you have just seen, except that in this one we actually show GitHub Actions integration. And then there is obviously a link to the docs. And in there, there is a getting started, which explains step by step what needs to be done in order to have Ike, which is the CLI name of Istio Workspace, running. As you can see, it's not that many steps you need to do. I mean, obviously, it requires Telepresence to be installed, so you will have to follow the guides from Telepresence.
Awesome. We've got a question coming in from Tim, and if you want to follow up, you can unmute yourself too. He's asking, can you manage access control so that multiple developers can create their own dev routes with Ike, but cannot modify the production flow?
Aslak, you want to take this one?
Yeah. So currently there's not much. Excuse me. So currently as far as developer needing access, the only access he requires is to be able to create the session object plus what is it, pod exec or something. Beyond that, it's the operator that actually does the changes to the deployments and to all the other services. Not something the developer needs access to. Yeah. It essentially needs the pod exec to connect and execute something in the Telepresence proxy to start up the incoming traffic, I believe it is.
Okay, and so I think you answered his question. I don't see a follow-up there, so that's good. So
yeah, sorry to drop.
That's all good. That's quite all right. So going back to all the names that you've mentioned here, what is the relation of Kiali to all of this work?
We just use Kiali to visualize, because Kiali is Red Hat contribution to Istio. It's a part of Istio right now. It gives you a nice view of all the things which are happening in your service mesh. But as far as our work is concerned, we literally just rely on it as part of the demo so that people can see how it looks in action, rather than just, seeing the curl running in the loop. But we don't really do anything with Kiali per se.
And so, and this I think is probably some of the setup for this AMA was a little confusing. So I apologize for that, because I was expecting something slightly different today. So and that's okay. And I actually really am impressed with the Istio Workspace stuff. So this is rocking awesome. So the Telepresence project, is that one you guys are contributing to, or are you just leveraging it the same?
Well, we do both. We wanted to have this running smoothly on OpenShift. So we started using Telepresence, and we started contributing patches. So we fixed a thing or two over the last year or so. So it's not that we are just consuming it and using it as a part of Istio Workspace. We are actively involved in making sure that this works as good as on vanilla Kubernetes on OpenShift.
So anyone could use this with any vanilla Kubernetes?
Right.
At the moment? Perfect.
Right. So we do have tests for this project, obviously. And we run it both on OpenShift and on Kubernetes. And as far as quality of our tests is concerned, work in both. So I think you can easily give it a try on any of the Kubernetes distribution.
And I think that would be interesting to me, and this just from an open source side of things is to make sure that everything works on both places and or any place, because there's like 99 Kubernetes distributions out there at the moment.
So we only have 2 different jobs, so we don't test the remaining 97.
Really? Okay.
Yeah, unfortunately.
I know that someone should write the test harness for that. Like, here's your project, boot up 99 Kubernetes and test your stuff there. That would be an interesting test harness to get organized and set up. Maybe that's a CNCF.
Totally.
Yeah, that'd be massive. And they are constantly changing in different flavors and different value adds and different versions. So it might be the impossible task. So where do you see this going next in terms of this? Do you see pushing it into the Istio project itself, or is it standalone, or what's on your roadmap here for this? You just want feedback?
Well, so we didn't really discuss yet if we want to make it part of Istio. So that's not really, I mean, we didn't really give it much thought. We are more focusing on the developer experience as such. So what we have on our roadmap next is definitely not only having a CLI tool, because not every one of us loves terminal. I guess 99.9%, but we also want to have a IDE integration. Mm-hmm. So that's something which we are gonna focus on next, sure. And we also are exploring integration with CI servers, because that's another part of the flow where we want to have our tool involved. So we did demo the Tekton part, and we also have integration with GitHub Actions, but we'll definitely looking for some feedback from people using, for example, Jenkins or something else, because we definitely would like to make sure that this is as useful as all the other platforms we tried so far. So these are the main 2 themes which we.
And would you? And I'm asking a lot of questions. I apologize because it's a new topic to me. But any other Envoy-based service mesh, would you be able to use this with Kuma or anything else, or is it still it's strictly right now? Are you looking to the other Envoy-based service meshes at all?
Well, as is right now, it's pretty much Istio, but we would definitely like to figure out some integration with the others. I'm not sure, Aslak, if you looked at the other meshes to see how much it takes.
I started looking at the what is it called, service mesh API, or the kind of the standard definition there, and it seems like there are at least a couple of features in that specification that seems like it will be able to at least do parts of what we want to do, not the complete picture yet, but at least part of the packet split and so on. So it should be doable, and we're probably going to move to try to follow that specification at some point. Currently, it didn't seem like there was anyone who actually implemented that specific spec change yet, but yeah.
Yeah, well, that's you put out an API and a standard, and you got to make people work on it. But yeah, that was the other, because there are a couple of other, at least, emerging Envoy-based service message. So if you get that dependency on Envoy, then the Microsoft effort around open service mesh is coming. It's starting to mature, as well as there's Kuma Kong. The other one is Linkerd. It'd be interesting from a community development point of view, which is where I come from, is to see this work wherever, and to have one unified CLI for all of this, and point it at whichever one we needed or people were working with. There's another question that's just come in. The Telepresence extension will be like WSL or SSL extension in VS Code. Have you explored that?
Sorry, once more?
It's in the chat there. It's coming in from the Twitch channel, that Telepresence extension. Will it be like WSL or remote SSL extension in VS Code?
Oh, I guess kind of similar in a sense, yeah. I think the whole remote VS part, if I remember correctly, it's kind of based on moving the file system out into the remote thing and do a file system sync. Telepresence, yeah, I guess that does that essentially as well, but in a bit of a different way. But like, yeah, we were actually looking at it earlier, whether or not it would make sense to use that new remote API, but it's a while ago and I don't quite remember what we concluded, but it's an option, possibly.
Is there anything on the Telepresence IO site about the extension, or is that something that's specific to your project?
Well, I can't recall anything on the Telepresence site about that, so no, I don't think so.
But I mean, is there a Telepresence extension or not? I don't think so, is it?
No, last time I checked, they didn't mention anything like that. So I guess it's more, our effort to get the Istio workspaces CLI tool, which we are demonstrating, to work with VS Code rather than Telepresence itself.
Yeah.
Cool. Well, I'm curious to see where you guys end up going with this, and how it all ends up working with all of the other developer tools that OpenShift has as well, all the code-ready workspaces and other things. So I think this is really nice enhancement to the efforts that people are doing to make it easier for developers to make our lives simpler. So I'm grateful for that. I'm not seeing any other questions out there in the universe, so you must have done an awesome job. Do you have a final slide for resources and how people can get a hold of you if we need to?
So I think I'm still sharing the repo page, right?
Is that how you want people to give feedback?
No, I mean, you could, well, so we don't really have a Twitter channel. So that's, I mean, as far as the feedback from usage is concerned, that's the right place for sure. So we can open issues or raise questions, right? And this is essentially where we live right now. Do we have any other channel, Aslak?
Not really.
No. So if
Well,
people
we probably should, but we don't.
Yeah. Do you see this coming out as sort of a standalone effort? I guess is there somewhere coming out from underneath Maestra and standing on its own as like a set of developer or part of the developer tool suite?
Well, I mean, essentially we are addressing developer experience gap in the cloud environment. So I think this can be perceived as a more development tools effort than anything else. As a matter of fact, we are talking with code-ready workspaces and chat people about how we could integrate. I mean, we did already a few workshops where we show that our stuff works with chat and code-ready workspaces as a part of a broader cloud development theme on OpenShift. So yeah, I mean, this is the place where we definitely belong in a sense.
Okay, so I think that'll be interesting to see how all that comes together. I mean, I for one would love to see it out there so that it works with multiple service meshes, not just Istio, but others, I think, and then that would be cool. And then if we can get it integrated in with the code-ready workspace experiences, that would be super awesome for everybody and easy for people to access it and find this work. How old is this project? Like, how long have you guys been around, and how many folks, do you have any folks using it in production yet, or is this just spanking brand new?
You can say it's brand new, as in we don't know if anyone is using it in the production. So it's been more like, R&D kind of effort for a bunch of months. I think the site or the repo says it's 1 year old or something like that. So yeah.
All right. Well, I think what I'll try and do is I'll reframe the paragraph that I wrote up with Kevin about what this talk was all about, and see if we can't push this out and get some feedback and more people using it, and see if we can get you some more issues. Hopefully not painful ones to fix, but good feedback on the project. It looks like something that's incredibly useful. So I'm really glad that you guys came today and made this happen and clarified a bunch of things for me, and hopefully for a lot of other people as well. So thanks again for your time today, and much appreciated. And if you,
Thank you.
When it comes back to another iteration, please feel free to come back and we'll do it again.
Absolutely. Thank you very much for this opportunity.
All
Much
right.
appreciated.
Take care. Be safe.
Take care.
Thank you. Bye-bye.
Recording has stopped.
So I think that was awesome. And I apologize because what Kevin had asked me for was an AM